For our ME106 mechatronics project, we designed an automated pet door that is controlled by ultrasonic sensors and a RFID module. Many of the options available on the market today are incredibly expensive, and many pet owners are priced out from owning an option like this. Our goal was to make an affordable RFID pet door that could be made with simple parts and could be used by any pet owners. On screen, you can see the basic code flow of our program for this project. The main part of the program runs in a continuous while loop that is constantly checking the ultrasonic sensors both inside and outside the house 10 times per second to search for the pet. If the pet is detected inside the house at ultrasonic sensor 1, the door will open, wait for a few moments for the pet to exit, and then close the door. If an object is detected outside at ultrasonic sensor 2, the program will begin initializing the RFID sensor to search for the correct tag for the pet. The code will loop the RFID scan program for 5 seconds, and if it doesn't find a tag, it will begin searching the ultrasonic sensors again. If it does find the tag, it will let the pet inside by opening the door, waiting for a few moments, then closing the door again. The purpose of using an RFID sensor as opposed to only using ultrasonic sensors is to verify that the pets are allowed inside the house and that other intruders are not welcome, will not be able to enter the house. As a proof of concept for our design, we made the assembly out of cheap materials like 3D printed parts and plywood. A user making this for their home would use an actual door and have to cut the hole out using a bandsaw or a similar tool. For this prototype, we also used a draw power supply to supply the circuit and the motor with power. In the future, we would design the circuit to run off of battery power or solar power so that no additional cables were needed for the circuit. For this project, we used a Raspberry Pi Pico as our main microcontroller for the interface. We chose this controller because we already felt comfortable using it from projects in this semester. It was cheap and available, and it had enough GPIO pins for us to use all of the sensors we needed for the project. The RFID sensor was the only sensor that ran on 3.3 volt logic, and the ultrasonic sensors required additional resistors in order to create the proper voltage levels for the logic to be read by the Pico. The motors ran off of a draw power supply, and then they were controlled by a driver board that were connected with 8 pins to the Raspberry Pi Pico. The RFID sensor that we used was not consistently strong enough to detect the tags at ranges that were convenient for the pet or for the owner. In the future, we'd like to experiment with different modules to see if there's one that works at a far distance and is also affordable for the average consumer to purchase and use reasonably. The motion for the system was driven by 2 unipolar stepper motors that were attached to gears and a door that formed a rack and pinion type motion. This design was chosen because it was easy to model and 3D print, and the analysis was rather simple for the kinematics of the motion. In the future, we'd like to experiment with other types of motion systems, such as a belt-driven door that would be a little more complicated to design but would work more efficiently with fewer tighter tolerances. So on the outside, if the pet is detected at the ultrasonic sensor outside, it's going to search on the tag. And then if it finds it, it's going to open the door. It's going to stop for a few moments so the pet can get through. And then the door is going to close. Now, if we're on the inside, there's no RFID sensor, so it's just going to detect the pet at the ultrasonic sensor and then open the door. It's going to allow it to open in a few moments. The pet's going to go through. And the door is going to close.